So in this video, Mr. Dimitrich, what we want to do is we want to learn about something called empirical formula. But I think we want to start with this example first to help them get a perspective of what it is.
Yeah, up to this point we've been doing percent
composition,
right? So we're going to do something that is a percent composition, and we're going to show you how we can work both ways with this. So
we've done this before.
Yeah.
Percent composition of carbon dioxide, we're going to just, carbon weighs 12, oxygen weighs 16. I'm rounding, I know. You're going to want to be a little more precise than this, but
it's 44.01 grams.
44 grams, roughly, right? So the percent composition would be 12 over 44, right?
And when we do that, I believe that we get
27 point, I had it here in the computer, 27.27%. And then the rest is oxygen, so let me, 72.73, right? Percent. Okay, and now what we want to do is we want to actually see if we had the percentages, these percentage of carbon and percent of oxygen, could I find that it was carbon dioxide? The answer, of course, is yes. And here's the statement, okay? Copy down this statement here, and it's kind of a mantra, and it's kind of rhymes. So it's percent to mass, mass to mole, divide by small, times till whole. So you got that? All right. So percent to mass. So we want to find out the percent to mass from here, right? So we got carbon, which is 27.27%. What are we going to do? Percent to mass, what does that mean, Mr. Dimitrich?
Well, it means that we want to figure out the number of grams we have. So since we don't have grams here, what we do whenever we have percentages, we pretend we have 100 grams.
Easy, right? 100
so if we had 100 grams and 27.27% of it was carbon, wouldn't we be okay with saying we have 27.27 grams of carbon? This is just a trick, Jedi trick.
So, and let's go ahead and write the next one, 72.73 grams of oxygen. And now we want to say percent to mass, mass to mole. So let's convert both of them to moles. So we do a mole conversion, just simple gram to mole, one stepper, right? 12.01 grams into 1 mole. So now I'm going to figure out that in the other one. You set that up and I'll do the math here.
By the way, I'm using 16.00 grams of oxygen. You could have on your table 15.994.
2.27. 4.55.
Now, I'm going to jump in here just for a second because I want to show you something here. These numbers right here, these mole ratios, that's actually the mole ratio. That's what the ratio is between these two elements. So we could actually write, if we wanted to, C 2.27, oxygen 4.55. This is the correct numbers, but is there something wrong with this right?
Yeah, we want whole numbers. So remember, it's percent to mass, mass to mole. Now we divide by small. So you look at the smallest number, 2 is smaller than 4, whatever. So you divide both of them by the smallest number. So 2.27, I don't need a calculator on that one, is of course equal to 1. But if I take 4.55 divided by 2.27, what I get is 2.004. So when you get this, guys, that's close enough to 2 for all intensive purposes. So this gets us CO2, 1 carbon and 2 oxygens.
If you remember, didn't we start off with CO2 to begin with?
Yeah.
So we can work backwards and forwards and get to empirical formula more than one way.
And speaking of empirical formula, what is the empirical formula? What is the definition? You want to write this down. It is the simplest whole number ratio of a compound. We don't say C2.270 4.55, we just say CO2.
And by the way, just for the way we do it, we typically don't write a 1 when there's only 1 of something.
Good point.
So we don't write.
So this example, what is it?
So we're going to go do another one where we do percent all the way through to empirical formula.
Okay.
We're going to go, if you read it off for me,
32.64 percentage phosphorus, P, element P, and 56.36 is the oxygen. So again, percent to mass. So let's do the percent to mass.
So here we're starting with percentages. We're going to pretend we have 100 grams. So when we do that, I'm just going to write it down here, 43.64 grams of phosphorus and 56.36 grams of oxygen. Now let me pause here for a moment. We're giving you percentages. They could actually give you the grams of both things and we wouldn't have to worry about pretending we have 100 grams. But every time you have percentages, your first step is going to be just to make this into grams.
So of course you want to convert to moles. Simple gram to moles. The molar mass of phosphorus is 31. Actually, it's like 30.
Can you give me the exact number?
His exact number is 30.97.
Why did I put this on the bottom?
Because you want to get the grams to cancel. and then 56.36, and of course that's 15.999 or 16.0, depending on how you want to do that.
We'll do the extra rounds here. That allows me to cancel my grams, and he's frantically doing the mathematics here.
So the first number is 1.41, and the second one is 3.52. So what we did, percent to mass, mass to mole. Next step is divide by small. So we're going to divide by small. Obviously 1.41 is the smallest number.
Oops. So this is going to give us a 1, and
Yeah.
I never have trouble with that.
Yeah, 1. And then that's going to be actually 2.49.
2.49.
So on this one, guys, the issue, of course, is that's not, so percent to mass, mass to mole, divide by small. Now this is the one that gives you, and then we say times till whole. So we can multiply by some number so that we get a whole number. So how do we do that?
Well, as it is right now, this is what we've written. P1 O 2.49, or we can even round it to 2.5. But we can't have that, right?
Yeah.
So what we do is we're going to just pick random numbers, the smaller the better, and try and multiply both these by it to get to a whole number.
And obviously if you multiply by 2, 2.5 times 2 is 5.
Right, and so, I mean, in case you were wondering, we just go times 2. Let's say that didn't give us a whole number, which it will. Then you times by 3. Wait for it. If that doesn't work, we times by 4, by 5, by follow it through. In this case, it's kind of nice because if we multiply this by 2, wouldn't that give us 2 phosphoruses?
Yeah, and then 5 O's.
And would give us 5 oxygens.
Now, one thing that I've done, Mr. Dimitrievich, that might help is that if your fraction, if your smallest number, the 2.5, if it ends in 0.33-ish, it could be like 0.35 or 0.34. Sometimes it's not exactly accurate. You're going to times by 3, because if you think about it, that's a third. If it ends in 0.5-ish, 0.49, you times it by 2. If it ends in 0.67-ish, you also times it by 3 because that's 2/3. We're probably not going to give you problems where you have to multiply by 4 or 5, things like that. That's going to be very rare. So
I pre it because you might get ones that are 0.116, and that's just mean. That's when you have to multiply by 6. There are times, and that's where the class is kind of separated.
yeah. But you can, but that's the general. If you really want to know, 0.2 is, that's times 5, right? 0.25 or 0.75 is times by 4 because it's like fourths, fifths, sixths. If you think about it, that's how you do these problems.
Probably not what we're going to be facing, but
yeah. So in our class, typically it's just going to be a 1, 2, or 3, or 1, obviously.
Can you teach me that rhyme again here, because that's really going to help us out here?
Percent to mass.
Percent to mass, mass to
mole.
mass to moles.
Divide by small.
Divide by small and
times till whole.
Times to whole. Hold on to that because that's going to help you with these problems.
So, Mr. Demetrius, let's do one more example. That's the example you guys are seeing right down here, and we know something about lead, right? So it's 60 grams total. Our lead total is a certain number, right? 38 point something, right?
So if you take a look at this right now, they give us the grams of PB, they gave us the grams of carbon, and they're like, "Raw, no grams of hydrogen."
So we have to figure out what that number is. But that's, if we know the total is 60.
Can we subtract these two from that 60?
Yeah.
Which he's going to do right now. And this question mark magically becomes
3.77.
3.77 grams. Once we get to this,
it's percent to mass, mass to mole, divide by small, times to the whole.
So now we're just going to use our molar mass from our periodic table, which he's holding in his hand. For each one of these,
207.2 is Mr. Leadman. Carbon, we know that to be 12.0. Yeah.
I do want to say something here as we go through this. Often with gases, they appear as partners. For example, hydrogen is H2 and oxygen is O2. I want you to be really careful here because sometimes we'll get in the habit of doing that so often that in here we'll go, oh yeah, that's H2. But our whole point is trying to figure out how much of these things we have. In fact, if I were to write the skeleton formula, it'd be this: PB with an X, we don't know what it is. C with a Y, we don't know what that is. And H with a Z.
All right, so 38.43 divided by 207 on my calculator says 0.185.
Okay.
And then 17.83 divided by the 12.01 number is 1.49. And that's 3.77, of course, because it's basically divided by 1. So percent to mass, mass to mole, divide by small.
Small.
What's our smallest number?
This is gonna be 0.185 here, right? So we're gonna divide all three of these by 0.185. If you're having trouble dividing something by itself, we can meet afterwards. But I'm gonna divide each of these by 0.185. I got lazy here and I didn't put moles on the outside of this, but do realize that those are moles because grams canceled in all of these cases.
All right, so I get it to be 8 for the first one, 8.0, or 1, of course. The second one is 8. And when you take 3.77 divided by 0.185, you get 20.33.
That's just mean.
Yeah, so what do you do there is percent of mass, divide by small times till whole. So we have a 0.33. I remember just a minute ago I said if it's a 0.33, that's like a third, so you multiply everything by 3. Now careful folks, you multiply everything by 3, not just the 20.33, but all of them. So that's going to be PB3, C, 8 times 3, 24, and that's going to be 61, right?
I just work here.
Okay.
So you're gonna put it.
That'll be 61. I can do that ahead. Yeah. There you go. PB3, C24, H61.
By the way,
Crazy.
it's kind of important here. Empirical formulas, you cannot reduce them anymore and still have a whole number. So if you take a look at this, there's nothing you can divide this by that will take you to a lesser number that has whole numbers in it. This is the kind of ugliest you're gonna get. And I'm really delighted that he, in the last example, said 0.333 because this is one of those that you just faced.
There you go.
All right, take care.